Hey, how's it going? And today I want to go over something that I call a recursive superfunction inverse. And this really is fairly advanced and it's mostly exploratory. I'm still going through what you could use this for, but I can tell that it has a lot of potential application. So I hope you find it of some interest. So anyway, what I have is I just have a verse device, and in my code, I have an array with just the days of the week there. Let's go and take a look at this. Like I said, this is fairly advanced, so I'll do my best to explain it as far as I understand. I call this a super function for a couple reasons. One is that essentially what we're doing is we're creating a function that we're calling super function, and it takes as a argument, one of its parameters is a function itself. So it's a function that we're calling with a function. And not only that, but it's also built at the module level. So it's not here on the kind of the class level, but it's really on the module level here. It's as far out as you can go. So it's kind of its own little creature sitting out here. And there's a lot of really interesting things about this when we get into this. I just did a tutorial about parametric types, and when we use the keyword where, we can essentially create a function that can accept any data type in. So it's a generic function that can be used in all different kinds of applications. And that's how arrays are built in Verse. They're built this way with generic data types so that they can be called with a range of data types like ints and floats and strings and things like that. The deeper you get into Verse, the more and more you'll see this. So what piqued my curiosity about this was this idea of calling a function within a function and then calling that function recursively. So we create this super function and then we call it recursively here. So it calls itself. And I found that interesting. And then there's some very interesting dynamics going on here. So let's kind of go through this one step at a time. So we have our device here, our creative device, and I have an array here called days, and it's editable, and it just has the days of the week in here. I should probably just make that mon. And that's pretty straightforward. Here's where things get interesting right away. So we have this array here, but what we're going to do is, an array is usually a single data type, right? But then there's an index value that's associated with each of those data elements. Here what we're doing is we're creating an array, this called index pairs, but it's more like a map, but it's an array. And so what it is it's basically a pairing of two items together, but it's an array, not a map. So we're pairing an index value with the data element here. So we have index and the data element is a string, right? But together, collectively, essentially what we're doing is we're creating an array of tuples because each individual item in the array has two elements in it, an index and a day or a string. The first interesting thing that we do is we're creating an array of tuples. So the data type of this array now, called index pairs, is a tuple. That's the data type. Then what we do is we create this super function, and it's going to take in an array is one parameter of the type called type, can be any data type. And then we are also creating a function that takes in an element and gives a generic output of some unknown data type. But it is of the type type. So U is of the type type, and it's an output here, and it's an output here for super function. So this function that we're going to send in, it has an output, and then the super function has the same output. What's tricky about this, the array element data type needs to match the function input data type. To call this super function, we're going to have to send it an array and a function. And when we call it with an array and the function, the array needs to be of the same data type as the input function. It's going to work in this case because the data type for our array is a tuple. So we're going to have an array of tuples, and our input for our function is going to be a tuple. So this is going to work because it's funny that T is for type, but T could almost stand for tuple. because that's what we're going to send in, our tuples. So up here, we've created an array of tuples, and then we're going to call superfunction with index pairs, this array of tuples, and we're going to call it with this function called word numbers. I call it word numbers, but it really should be called something else, but I'm calling it word numbers. We're going to call it with word numbers, and this function that we call it with, this function needs to match the overall structure of the function down here. So this function takes in a data input and it outputs another data type. So it takes in a data type of some type and then it outputs another general data type out. So that's what this does. It takes in a data type of a tuple and it outputs an integer. So that would meet the requirements of this. So what I'm saying is the function that we send to superfunction must match the structure of this function down here, which it does. So there's some limitations with doing this because things need to match up. Here, this function that we're going to send to superfunction, it essentially just takes in a tuple, which is essentially the individual element from the index pairs, which is an index in a day. So it's an integer and a string, the same thing. So it accepts that in, and it's going to return an integer. Since we're sending in a tuple, we can access the elements of the tuple this way. By word tuple 1 will access the string, and word tuple 0 will access the integer. So essentially all this function does is print out what it receives, and then it outputs an integer that we don't really do anything with except print it out. So this function doesn't really do that much. With our array built and our function built, we're going to call superfunction. Now the most interesting thing about this is that when we call this function with our array, then we will have access to this function and to this array. So down here at this level, even though we're operating at the module level with this superfunction, we will have access to this function and to this array. But the output from our function will only be available to us up here. So we can't access the output or the results of either of these functions, this internal one or this external one, only up here, not here. So here you'll see where I call superfunction, I can assign the result to this identifier called results. If I was to take this line of code here and put it down here somewhere, I'm going to get an error. So let's say I put it right here. You'll see it won't work down here. So it's very interesting. There's some real limitations with this system, but the possibilities that it opens up are really powerful. Let's walk through what happened. So we have our array, we have our function, we go ahead and call here, we send it in, and the first thing we'll do is going to run through its logic once it's called. So it's going to print out that it's been called, and that's going to be on the screen for 10 seconds. Then it's going to go to sleep for a second, and then it's going to check the array. And when we call array, right, we're calling here, but what we're really calling is our index pair array here. So even though these appear to be generic global functions, they're really giving us access to our array that we sent in and our function that we sent in. But we're not calling this index pairs, we can call it with just array. So when we call this super function initially, essentially what we're doing is we're instantiating this super function with what we sent into it, which is really interesting. To access this array index pairs, we can just call array here. So I can get the length of the array. So when I call array, I'm really calling index pairs. And when I call function, I'm really calling word numbers here, right? So we have array length, and as long as our array has at least 2 elements in it, this logic will proceed. If there's at least 2 elements in there, then go ahead and remove the first position element and create a new array. And then what we do is, here's where we make a recursive call. We go ahead with our new array and call superfunction again. But now when we call it again, we have 1 less element in the array. And this is really interesting too, is that when we call function here, because we have to send it a function, we don't have to send it any parameters. We can just call it with function. So we can make a recursive call, and then it's going to just keep going through until there's only one item left in the array. And when that happens, then this is not going to be true, and it's going to kick down to here. And we're going to get that first item in the array, assign it to first, and then we're going to call function, which is word numbers, right? We're going to call it through here almost. And we're going to send it the first item in the array, and then we're also going to assign this value here, return, right? When I call this function here, I can get its return out of it here, right? But I can't get this one here, right? When we have a function, every out point needs to have a return type on it. So what we're going to do is we just call first function here, and when we make this call here, that'll print everything out here, and that'll be the end of the program. Because this will work, this won't get called. But if it were to be called, this essentially is just here to give a return type that satisfies the return value here. Or what's interesting about this is that if this weren't here, we could just do it with error. And I didn't know that we could do that. Is essentially error isn't acceptable as a catch-all return for everything. And it just kills the program because error returns a value of false. Normally you would have to have some sort of output here as a return, since we're saying this super function is going to have a return value. But error will take care of that. That's essentially it. There's a lot going on here, and so I hope I didn't present too much at once. But let's just take a look at this in the code and see what this does. So I'll just go ahead and build the verse code, and I'll push those changes, and let's see what it does. You could actually almost build a timer out of this. So you see we're calling super function, and it's taking that 1 second sleep. Super function called, and then there's the very last print statements that come out. And you can see the last element left in the array was index value 6. So anyway, I hope you found this helpful. I will be posting more tutorials about this and its potential application. Anyway, take care, have a great day, and I'll talk to you next time.